All right, how's everyone doing? Good? Not too bad, right? It's a little warm, but yeah, we all can deal with that. So yeah, welcome everyone. So we'll talk about some basic wheat agronomy here. You guys have looked at some varieties, some disease stuff. So we're gonna talk a little bit about basic agronomy, how we can set our wheat for a high yield potential, right? That can help us maximize the profitability, right? That's generally been our issue with the wheat, right? To increase area under wheat production, it has to be profitable, right? So what we can do to maximize the yield potential without spending too much money doing that, right? Otherwise, your cost of production goes up, then you don't make as much profit. So let's talk about yield potential. Give me a number. What are you guys chasing in terms of wheat yield? 135. 135. Anyone else? 300. Who?
I was in Saginaw meeting and the guy grew 600.
Anyone knows what's the world record for wheat yield? 260. Cheating. Dwight, you were over there. You met the guy a week ago. So yeah, almost 260 bushels. That's a wheat yield record, right? So again, there's a lot of potential where we are in terms of where we can be. Their environment, their weather is a little different. So again, we have to keep that in mind, right? They have a really long grain fill duration. Their temperature stay in that ideal 65 to 75 degrees for a long time. But yeah, anyways, you all have the handout in your package. So yeah, once you go back, all the information we're going to be talking here is available in that. We have done a lot of work on agronomy. I have had multiple grad students doing this. I saw Calvin, he is somewhere in here in the crowd. He got started on this work. Then Patrick, my research technician, he did some work. Then we had Paulo over here. He's been doing some work, working with Eric Olson on wheat varietal side of things. And Wallace is doing the work that you will be seeing over here. All right. So you see again, in terms of achieving this high yield, what do we need? Right? The one main thing we chase in our program is how do we develop this canopy that can maximize sunlight interception, right? That's what we are chasing, right? Converting, first intercepting that sunlight, converting that into biomass, and then into the grain that we are harvesting, right? That's pretty much what we are doing, right? So how do we develop that canopy and do it while we are planting our crop, right? You can see a couple of bullet points here. We have done a lot of work on planting time. Of all the variables we have looked at, planting time seems to have a really big response. Wallace, you have a couple of those plants here, right, that you can show around. These two plants, you can see the difference, right? How much tillering there was, and you can pass it around. That when we plant soon after that Haitian fly free date, we are able to produce those 3 to 4 tillers that is maximizing our yield potential, right? We have done a lot of work on the seeding rate side of things as well, seeing the potential to maybe cut down our seeding rates. What's a typical number you guys are seeding at now in terms of number of seeds? Not talking about seed weight. Anyone can give me number of seeds per acre? 1 million. 1 million going once, going twice. Anyone want to go higher than that? Go higher, right? 2. Okay, we are probably going a little too high. I think I've heard a lot folks seeding around 1.5 million or so, even for timely planting. We have done a lot of work. I have some extra handouts here showing that for timely planting, we can bring it down. 1.2 million is probably a pretty good number. Just cut it down by 20% or so, throw some strips out there and see how that works for you. All right, what else on here? So the last 2 years, we were even looking at some of the faster planting technologies. You all have been aware we have had a hard time getting wheat in ground, right? Because it's too wet. Those damn beans are not maturing on time, and then everything is delayed, right? And we are delayed, or we can't even get the wheat planted. So we have looked at different planting equipments, including even broadcasting and then incorporating that seed. And we were surprised to see those yield results. No reduction in yield compared to seed drill. But again, that's a short-term solution. Long-term, where we are heading in our program is looking at narrow row spacings and maybe adding a precise seed placement component, and then thinking about what else do we need to be doing as part of that system to maximize yield. Couple of you did go to UK with that yen tour last week and got to see those narrow row systems over there. The type of varietal canopies they are using over there, you will get to see a couple of those over here. I've been working with Eric Olson trying to look at that aspect, do we have variation in our varietal canopies that can take advantage if we want to go in a narrow row spacing system, all right? We have seen, so with Calvin's work, I think we saw about 5 to 10% yield improvement going into 5-inch row spacing compared to 7.5. That sounds about right, Calvin? Right? So yeah, it was dependent on the year, dependent on location, but we did see a yield benefit. We were not sure, is it coming from narrow rows or going in with a more precise seed placement, right? I think we have more data now for me to feel more comfortable that, yeah, the benefits are mostly coming from narrow row spacing. So again, that is the system I think we are going to be chasing here. That does trend with those really high yields we were talking about with those UK growers, right? Let's see. Any questions so far? I'm going to turn it over to Wallace so he can talk about what you are seeing here out in the field.
So when you go to 5-inch spacing, are you holding the same population you're using in, say, 7.5?
Okay, so the question is, as we go into these narrow row spacings, how about those population seeding rates? Are we keeping them same or are we changing them? We did do that work with Calvin. The idea was, as we go into narrow rows, can we actually push to higher populations, right? Something we have tried on the corn and soybean side of things. That did not really turn out to be the case. So that does not benefit. If anything, you guys have a cartoon on your handout. There might be a benefit of keeping that seeding rate low, because with narrow rows, if you keep low seeding rate, you get more seed to seed spacing, right? Because you have more linear footage to work with. That can help plant tiller out. And that can even help the uniformity of those tillers, right? So when you go for that fungicide application for headscap control, you in theory get better control out of that. So I think that probably goes hand in hand. Go in narrow rows and don't go to high seeding rates.
And then secondly, are you seeing overall a lesser disease rate in the narrow rows because you're getting better spacing with the population being the same?
Okay, so the question is, how about disease pressure in these narrow row systems? That is something we are still actively looking. I think this next year, I've been talking to a few other researchers, and we're going to look at multiple fungicide applications. Because again, what we learned in UK was, yeah, as you go into narrow rows, you might actually have to deal with the higher disease pressure because the air movement is not there. You might have high humidity within those canopies, right? Yeah, you get more uniform tillering, and you can get a better efficacy of fungicide, but the disease pressure might actually be higher with those canopies.
I would be curious if you went even lower population in those 5-inch rows, planted on time, may alleviate that and give you bigger hits and get all your yield.
Yeah, so that's a really good point, and that's the hypothesis I want to really evaluate, and we might be able to get away with that. Because again, unlike the environments in the UK, we don't have those cool temperatures for a longer period of time, and we don't get rain every day. So yeah, I'll be really curious to get some research trials and get some data on that aspect. Christy Sprague and I have been talking about the weed control piece there. This year, Wallace did see that, yeah, these 5-inch spacings, they were really shading out those weeds. He had plenty of chickweed here, I believe, right? And that was really getting shaded out. All right, I'm going to hand it over to Wallace so he can explain what's going on here.
All right, thanks Manny for the opportunity to be here talk today. So here we have in our field basically the objective of this study is to see how we can maximize the productivity, the yields here in these row spacings, the different row spacing systems. So basically these narrow rows are achieved using a precision planter. So we have precision planter versus drill. In precision planting 3 row spacings, 5, 10, and 15 inches, and drill in 2 row spacings, 7.5 and 15. And we have seen pretty much the benefit of going to narrow rows. In the back of the handout here, we have my first year's results, where we see that these narrow rows, 5 inches, achieved better yields compared to 7.5, and it kind of goes down once you go to wider rows. We have also seen here that erectophile canopies, we have this canopy piece that we are also studying. That's a focus of Paula's study, but we also have it here. As we go to narrow rows, can we explore these different canopy architectures? We can go to narrow rows with erect canopy types and have a better distribution in light. We have a figure here where we measure lights in different sections of the canopy, and we saw that planophile canopies, they are more droopy, they intercept more light, but at the end, the erect canopy types, they are achieving higher yields. If you see in this figure here, you see that the head red points, they are up, especially on the narrow rows. So they have better yield potential in narrow rows, basically. We also study different seeding rates. One part of this field, we study different seeding rates going from 0.4 million plants per acre to 1.6, 0.4, 0.8, 1.2 and 1.6. And we have seen that when we combine these narrow row systems with a precision planting equipment, we have seen these, we have potential to cut down seeding rates as we distribute these plants in narrow rows. That's what we have here as well, these seed cartoons showing that once you go from 7.5 in a high population to 5 inches, you have a better distribution of these seeds on the soil. Basically, you give more space between seeds to these plants to grow and achieve higher yield potentials. Same with the drill. If you go to the drill 7.5 and you go to lower seeding rates, you have better distribution of seeds. Then once you go to higher seeding rates, the drill are going to distribute more seeds per row, basically. Yeah, that's basically what I had to say. Manny, do you want to add some final conclusions?
So again, I think in terms of this row spacing again, the $1,000,000 question is again, what you guys can use to plant in narrow rows, right? That's where we are working hard to generate data that we can show to industry, narrow rows work. Europe is on this system. We used to have, Dennis, right? Back in the day, we had plenty of narrow row drills. For some reason, industry has moved away from that. And we are out to, again, get them back into this game, go into narrow rows. And again, in terms of investment, we are thinking multi-crop equipment, right? We are doing a lot of work on the soybean side as well. Soybeans do respond to narrow row spacing as well. So we are looking at some 15 or even going to 10 or even 5-inch row spacing. At least in theory, I'm thinking again, if a system out there can plant wheat in 5 inches and then soybeans in 10 or 15, that's probably a win-win scenario, right? And we don't need to have all the bells and whistles. I think precise seed placement does pay off, but I think it's not as big of a deal in both wheat and soybean, because wheat is able to, you can see over here, tiller out, right? Plenty of tillers. That's our goal. While soybeans, what do? They branch out, right? What does corn do? Nothing, right? You have to babysit those plants, right? That's why having more precise technology, everything at VE, V1, in corn world, that does pay off. But I think in soybean world, just like on the wheat side, narrow rows probably are a better way to go. So that's where we are. We are trying to generate more data, develop this narrow row system that hopefully can give us this improvement in yield potential without again spending too much money on a year-to-year basis, right? Upfront cost in terms of investment in a new system, or again sort of working with your current system and see how you can go into narrow rows. Questions? We still have about maybe 5 minutes.
Is there much yield difference between broadcast and 5-inch rows?
Broadcast in 5-inch rows. You have that cartoon? So yeah, Patrick did a lot of that work, a lot of data here. So between broadcast and drill, no difference. This was all done on farm. Some of you guys did host these trials. Yield potential anywhere from 60, 70, all the way to even 150 bushels, no difference. But yeah, when we went to the 5-inch row spacing, we did see a yield improvement. 5 inches narrow rows were better than either drill or broadcast. So yeah. Others? Come on, I'm not letting you go on unless someone asks more questions.
When's that rain going to hit us?
I wish I had the magic globe to give you that answer, right? I don't. Okay, seeding rate. We have a cartoon on that as well. So you can see what we are seeing here is, if it's in September, about 1 million is plenty. Early to mid-October, 1.2 to 1.4 or so. After mid-October, at least 1.6 million, if not more. So if you are 1st of November, I would say 1.8 or so. So yeah, sequential increase. The critical point there is that just bumping up seeding rate with delay planting does not get you back to the yield potential that you had in September. It's minimizing the loss, but the loss is still going to be there. Anything else on wheat agronomy? So again, I thought it's kind of hard to see these differences in wheat canopies now. But again, what we saw in UK, all of these wheat varieties were pretty erect. Right? And we have done that work in corn. Those hybrids back in the day used to be more of these droopy, floppy kinds. Over time, the breeders have been working to make them erect so we can fit more in a given area, right? That's the same concept we are chasing here. And I think what's happening in UK, since they are planting everything in 4 or 5-inch rows, they are doing their breeding work in that system. So over time, you get moving towards those systems. So Eric and I are going to be spending time trying to see again, is that part of this narrow row system that is really working for folks out in the UK, and can we make it work over here? And then add these other components, disease management, right? What are the implications there? Weed control, what are the implications there? Fertility management, what are the implications there, right? Do we need to go to higher fertility if we have a higher yield potential, right? So those are the questions we are trying to take that next step, right? To improve those yield potentials and make wheat more profitable. Do we still have time? Any last minute questions? All that we discussed, it's on this handout. If you go to our website, agronomy.msu.edu, everything is over there as well. Feel free to reach out to me, Wallace, Paulo. We have plenty of people with a lot of experience working in wheat agronomy. So we'll be really happy to answer. And I'm looking for any feedback. I'm going to stick around and see if you give me any feedback. Are we on target? Is there anything we are missing in this? Because we really need to move the ball in wheat production, right? That's the goal. How we can get those extra, not 5, maybe 10, 15 bushels, right? Without spending much extra money. And I think we are on the right track. Eric, I'm really looking forward to some of this work. Dennis has been helping us. So yeah, thanks everyone. Thanks Michigan Wheat for all the funding. And thanks everyone for stopping by.